Hey everyone, welcome back to our Sky Tonight program. My name is Seth Mayo. I'm the curator of astronomy for the Loman Planetarium. And in this week's episode, we're covering the dates of May 24th through May 30th. We're going to start things off by talking about Venus and Mercury very low in the west. We'll then shift our attention to the southeast in the early morning to look at Jupiter and Saturn. And we'll talk all about the moon for this week and how it's going to be a super flower blood moon, a lunar eclipse that will occur. So let's get to it. Now, if you have a really clear view of the western horizon, you have a chance to see a really bright object just after sunset, and that is the brightest planet in our sky, the planet Venus. Venus looks like a non-twinkling, very bright star. It really shines, and even with a little bit of the sun's glare in that area, you can still see Venus shine right through it. As long as you have a clear view of the horizon, of course, there's no clouds to block your view. So Venus will be there, and what's great is it is rising higher and higher in the sky until we get to the summer months, especially in July, and then it will start to descend back towards the western horizon. What's great is just above this planet is another planet right here. It's really tiny and pretty dim compared to Venus. Right there is the planet Mercury. Mercury, as we know, is the smallest planet in the solar system and the closest one to the sun. We talked about it last week because Mercury was at greatest eastern elongation, or greatest elongation east, most east of the sun, until it started to descend back towards the sun again because it moves so quickly in its orbit. So you'll find this planet just above Venus. If you're lucky enough and it's clear enough, you might have a chance to see that. But what's really cool for this week is that these two planets are actually going to get closer and closer to each other. So I'll keep Mercury highlighted, and we're going to move through each day of the week. So we'll go to the 25th, then the 26th, and notice how the planets are nearing each other each evening. Then to the 27th, and then by Friday the 28th, they're going to be really close. And they're so close you can even barely distinguish them in the video here. So let's zoom in a little bit more just to give us a better view of these two planets. Really close to each other right there. So they're so close, they're within half a degree. I think they're 0.4 degrees apart. And half a degree is a full moon's width. So they're actually a little bit less than a full moon widths apart, which means that if you're looking at this through a telescope, you'll be able to capture it through your eyepiece in one field of view. You can see both of these. A really bright planet to the right, Venus, as the hottest planet in our solar system, one that has a very reflective atmosphere of carbon dioxide, and that reflects back to us. And Venus is about the same size as Earth and relatively close as well, so it makes it brilliant. But then to the left, we have little Mercury right here, which is a little farther away from us, doesn't have a thick atmosphere reflecting light to us, and it is smaller as well. And so it's 280 times dimmer than Venus right now. But it's kind of cool to see a really bright planet to the right and not so bright planet to the left. These are the two inner planets in our solar system within half of a degree of each other on the 28th. So that'll be quite nice. If you're looking low in the west towards the western horizon just after sunset, you do have to compete with the sun's glare. And I always say be careful with the sun. If you're viewing in this area with binoculars or a telescope, definitely make sure the sun is below the horizon. But this is a nice celestial treat. And then after that, as we get past this moment here, you'll find that Venus will rise higher above Mercury, as you see there, and continue its upward trek as we get into the summer months. As we shift our attention to the east and southeast, and you're up very late or get up early in the morning, you're going to see two more planets, the biggest planets and much farther planets in our solar system, at least from us, rise in this area. So starting at 1:30, we actually have the first one that we can see out of the two that we're looking at here. That's the planet Saturn. That's just above the horizon. This is local time here at 1:30, and that's rising right there above kind of the east-southeast. And if you do stay up even later than that, getting closer to the kind of 2 o'clock time frame, 2 in the morning, then you'll find Jupiter rise as well, the largest planet in the solar system. And then from there until sunrise, we'll see them kind of shift to the west. We'll stop here at about 5:30 in the morning. So if you do get up really early in the morning and look more to the southern part of the sky, you may see these two planets. They're a bit farther apart than they were kind of earlier in the year. They're kind of spreading apart in their distance here, but they're still relatively close, or at least in the same region of the sky. And they're really nice, and they're getting brighter because we're getting closer to them. So as we get closer to them, they're actually going to rise earlier and earlier in the sky. And then later in the year, we're going to have a nice view of them in the evening. And then these two planets will be really great to see right after sunset. But for now, they're visible in the early morning. They're very bright and getting brighter. Again, they're going to look like non-twinkling stars, like we always say about planets. And as we move through this week, we'll find the moon will join these two objects. So we'll go to the 26th, 27th, 28th, and then by 29th and the 30th on the weekend, you'll see the waning gibbous moon join the scene with, again, Jupiter here, then Saturn, of course, there is the moon. So it's kind of nice to kind of watch these planets rise higher and higher, but they're still great for that early morning, especially if you're up before sunrise. You can take a look at these two very, very bright gas giants. For this week, the moon really steals the show because on the morning of the 26th, Wednesday morning, we're going to have what's called a super flower blood moon, or you could say a full flower moon. And I'll tell you why we have this big name for the moon this week. So super, as we've mentioned in a lot of episodes recently, is when the moon is close to us and full. It's what we also call a perigee moon. In its orbit, the moon can be closer to us during perigee or farther during apogee. A farther full moon is called a micromoon, and a closer one, a supermoon, a term that's sort of relatively new, not an exact term that astronomers use, but one that you hear kind of in the public sphere. And so there's a supermoon going on because of that perigee and full moon phase coinciding. Flower moon is what you call the full moon in May, and that's because the time of the year flowers are blooming. So it's one of the names of the moon at this time of the year. And then blood moon, what does that mean? Well, that is when the moon turns kind of a reddish color because it falls into Earth's shadow, something we call a lunar eclipse. These happen once in a while, and a lunar eclipse is when the Earth, moon, and sun line up in a perfectly straight line. There's also, of course, a solar eclipse when that happens as well, but the order is different. It's when the moon is in between the Earth and the sun. During a lunar eclipse, the Earth is between the moon and the sun. And in our planetarium software UniView, we can see this lineup in space. So you'll notice the Earth right here in the middle, and then we have the moon here. Of course, the moon goes around the Earth in its orbit, and then there's the sun much, much farther away at about 93 million miles away in distance. And if these things line up just right, again with the sun, the Earth, and the moon line up perfectly. They don't always do during a full or new moon. They're usually a little bit misaligned, but if they line up just perfectly, you get what's called a syzygy, a word I talk all about. I love that word. It's such an odd word in astronomy, but I love it. So we have the syzygy going on the 26th, and that's when the moon actually will pass into Earth's shadow right over here. So that shadow of Earth is cast out into space. The moon will fall into it and will turn a reddish color, and it becomes a beautiful sight. Lunar eclipses are great because they can be seen across a big part of the Earth. And that's the big question. Where can we see this particular lunar eclipse? Here's a great chart and diagram from NASA's eclipse page that helps us understand what's going on with this particular event. And if we look at the top, there's some details about the time and coordinates for the eclipse. And in the middle, there's a nice diagram of Earth's shadow and how the moon passes through it. First passing through Earth's penumbra, the secondary shadow, which really doesn't change the appearance of the moon very drastically, so you don't really notice much there. The main part you really want to pay attention to is when the moon enters the umbra. That's the dark part of Earth's shadow here, and it's tinted slightly red, and I'll talk about that later. That's why this circle is red. So if we look here, this starts at U1. These are contact moments, and down here it tells us U1 begins at 9:44 Universal Time. For us on the East Coast, that's 5:44 a.m. Eastern Standard Time. That's the beginning of the eclipse, and for us, that's not long before sunrise and before moon set, which means we don't get much time here in the East Coast of the United States to see this lunar eclipse, which is just the way things go. So that starts at U1, it slides into it. At U2, that's totality. That's when the moon is fully immersed in Earth's shadow, makes the moon blood red color, and that happens at 11:11 UT here in the United States, at least in the East Coast, that's 7:11. So we don't see it by then, and then it continues sliding across it that main part of the eclipse ends at 12:52 Universal Time at U4. Down here is a map that kind of explains where on Earth generally this can or cannot be seen from. So here in this dark section in the middle, that's where you cannot see any of this eclipse because it's daytime for them and the moon's not out. So that's for Africa, Europe, and parts of Asia. But then we get to the United States here and even South America, we can see the eclipse at moonset when the moon is setting. And here in the East Coast, we get a little bit of it, but the farther west you go, the more of the eclipse you'll see because it starts earlier and earlier in the morning. And then you get all the way out to the Pacific Ocean, you can see it says all eclipse visible. So if you're out in this area, especially where this little dot is, that is the great state of Hawaii. That's actually where a lot of my family's from. It's where I'm born. Little fun fact there. And so if you're in Hawaii, that's where you can see the entire lunar eclipse. That's one of the best places to see this. For Hawaiian Standard Time, this actually starts on Tuesday evening at 11:44 p.m. Hawaiian Standard Time. And then it moves into the early morning of Wednesday the 26th. Totality for them is at 1:11 a.m. Hawaiian Standard Time, and then moves through that portion of the evening until 2:52 a.m. So that's a great place to see it there, and even parts of Australia here, New Zealand, some of these islands here in the Pacific, and even parts of Eastern Asia as well. But they see it at moonrise. So when the moon is rising in the sky, they'll see a little bit of it as well, but not the entire eclipse. It's already happening as the moon is rising, and then it ends as the moon gets higher and higher for them. So it just depends on where on Earth you see the moon in the sky. So this is a great chart provided by NASA that can help us to understand some of these details. So going back to Stellarium and our view from the east coast of the US, we can see how little of the eclipse we can view, but it'll give you an idea of what to expect here. So we'll continue speeding through time here in the morning. This is early morning the 26th. In the 5 o'clock hour, as you see here, the time moving quickly. And you'll see how low the moon is in the southwest, kind of western portion of the sky here. And as the moon descends, as we get closer to 5:44, that's where that U1 contact begins. The main part of the eclipse occurs. You will just start to see the shadow right here. And I can pause the time and zoom in a little bit, and there's that shadow kind of entering the scene there. So we'll continue on, but look how low the moon is. But there's Earth's shadow, and hey, you can see the curvature of Earth. The Earth is round, there you go. But anyway, you can find that occur very low in the East Coast, but we at least get some of it. So if you have a clear view of the very low western, southwestern horizon, you may have a chance to see the beginning of this eclipse. If you find yourself in Hawaii next week, you really get a chance to appreciate this entire lunar eclipse. So I've transported us there here in Stellarium just so we can appreciate this to its fullest. So we're going to zoom in or hone into the moon just so we can watch this a little more closely here. And we'll speed through time. And like I said earlier, this starts at least the main part of the eclipse begins at 11:44 Hawaiian Standard Time, Tuesday evening. And so we'll start to see that here. There's that shadow of Earth again, and there's that curvature of Earth's shadow. And as we watch this happen, of course, the moon gets darker and darker as it gets immersed into this shadow. But as it does that, it starts to turn a reddish color. And that's because all of Earth's sunrises and sunsets are being cast onto the moon. And it makes it a blood red color. And what's really cool is notice how you saw more of the stars appear here because the light from the moon is dimming, that reflected light from the sun, and that allows you to see more objects around the moon. It really makes the sky change. So the whole process, not just the moon, but the sky all around it, is amazing. And you'll watch that happen, and then by totality, that's at 1:11 a.m. Hawaiian Standard Time. That's Wednesday morning, the 26th. Then the moon turns that bloody red color. This can change depending on the state of our atmosphere, so we don't really know exactly how it'll look. And that's for a brief moment until it ends, and then the shadow starts to leave the surface of the moon. And so you'll notice that here. We'll continue on, we'll go a little faster as we move the rest of the morning, and then at 2:52 or so, that's when it leaves that shadow and brightens up again. Notice how the objects around the moon kind kind of disappeared again. So now we can't see it because the moon is so bright again. So that's the entire lunar eclipse as seen from Hawaii. If you're wondering what a lunar eclipse looks like from the moon's perspective, well, here in Space Engine, we can place ourselves on the moon and look towards the Earth and Sun. This is just before the eclipse, or at least the main part of the eclipse, begins. And when this occurs, what's happening from the moon's view is that the Earth is eclipsing the sun. Kind of like during a solar eclipse on Earth when the moon covers the sun and darkens the sun for a moment. That's what's actually happening for the moon. It's sort of our solar eclipse in reverse, which is an interesting way to think about it. So we can actually speed through time and watch that from the moon. And this is right before, like I was saying, with the sun beating down on the moon, giving us a full moon. So the moon is getting a lot of light from the sun. But watch carefully here as that Earth seems to slide over the sun, or as the moon goes into Earth's shadow, we're going to see something magical happen. This is really awesome. So you're going to notice it, sun dimming, and I'll kind of stop at different moments here as this occurs and watch the Earth. There it is. So that is Earth right there. And you see that ring around the Earth? That is all of Earth's sunrises and sunsets simultaneously being cast onto the moon. And since our sunrises and sunsets are reddish because the light from the sun is being bent through that area and red light makes its way through more than the blues and greens, what happens is that color is predominantly cast onto the moon and turns the moon a bloody red color. So if you're on the moon, you have a reddish landscape all around you because of that red ring of Earth shining on you during totality. Now right here we can even see they've simulated kind of a solar flare or some type of prominence coming from the sun, because when something covers the sun, you can see the corona around the sun, the atmosphere around it, and it gives you an amazing view. Just like when a solar eclipse happens and the moon covers the sun, you see the amazing atmosphere around the sun you wouldn't normally see because the sun is so bright. So you get the same effect from the moon's perspective looking at the Earth, and that's what you see there. But again, there's that ring I was talking about. And so again, that happens for a brief moment. And so there's that total lunar eclipse, and it really is shining here. It looks really nice. And then it doesn't last forever because everything is moving. Really, the moon is moving continually in its orbit. And then you'll find the sun will kind of appear on the other side, brighten the moon again, and over time, light the entire disk again. And all of a sudden, it's a full moon, like nothing ever happened. And so to get that perspective really makes you appreciate a lunar eclipse in a whole nother way. As I mentioned earlier, here in the East Coast of the United States, we don't get much of this lunar eclipse, but as you move farther west, you get more and more of it until you get out to the Pacific, and in different parts of the world, you see different amounts of this, and at different times as well. So it's just fun to celebrate the syzygy and the super flower blood moon that we get on the 26th. So an exciting time for Earth's only natural satellite. Hey, that's it for another edition of Our Sky Tonight. Thank you so much for tuning in. Please stop on by the Loman Planetarium if you're in the area. Please visit our museum. And if you want more information, check out our website if you want to know about the shows, the exhibits, anything we have on display here at our museum. And with that, I'd like to say happy lunar eclipse viewing and, of course, happy stargazing.